VTP, VLAN Trunking Protocol, is a Cisco proprietary protocol that propagates the definition of VLANs on the whole local area network in the same VTP domain and provides easy management because you do not manually add or delete the VLANs. In VTP protocol, we have a VTP server which distributes and synchronizes the VLAN information. You can propagate the normal range VLANs with VTP, but if you want to propagate the extended range VLANs, you should use VTP version 3. This extended range should be distributed by using the VTP version 3, guys. Let's go ahead with the VTP modes. We have 3 modes. They are server, client, and transparent. Switch in the server modes. Create, modify, and delete VLANs and specify other configuration parameters such as VTP version and VTP pruning. Switch in the transparent mode just forwards VTP advertisements and does not participate in VTP. VLANs that are created, renamed, or deleted on transparent switch are local to that switch only. Switch in the client mode cannot create, modify, or delete VLANs. Guys, we're gonna make an excellent packet tracer lab about the VTP modes, and you'll see the difference between server, client, and the transparent on our lab exercise, and you will understand what is going on between these guys better. Let's go ahead with the VTP versions. We have 3 versions of the VTP, and they are VTP version 1, VTP version 2, and the VTP version 3. VTP version 1 is the default VTP mode. VTP version 2 is similar to VTP version 1, additionally supports the token ring, and VTP version 3 is the version that provides more security enhancements with the capability of supporting extended VLAN range. And let's go ahead with the configuration revision number term. Configuration revision number is a 32-bit number that indicates the level of revision for a VTP packet that used in order to determine whether the received information is more recent than the current version. This number is incremented by 1 for each VLAN change, and if switch receives an update with a higher revision number, this update is always used. For example, let's say that we have a VTP server in here. Let's say that which is switch 1, and let's say that this is switch 2 and this guy is switch 3. And let's say that when we create a VLAN in here, for example, let's create VLAN 20 in here. Because of this is a VTP server, VLAN 20 will automatically be created on this switch and on this switch 3 as well, as you can see in here. And as soon as I add the new VLAN to this guy, the revision number will change from 16 to 17 on everywhere, as you can see. Let's go ahead with the VTP message types. We have 3 VTP message types: summary advertisement, advertisement request, and the subset advertisement. Summary advertisement is sent by VTP server in 5-minute intervals to its adjacent switch and includes the VTP domain name and the configuration revision number. Advertisement request is sent if summary advertisement includes a higher configuration number than the current value, and subset advertisement holds the VLAN information. Let's go ahead with how we can configure the VTP. To configure the VTP VLAN trunking protocol on a switch, first we need to choose the VTP mode. VTP modes can be server or client or transparent, as you know. and VTP server is the default mode. Okay, to configure the VTP mode on a server, we are typing VTP mode and the VTP mode, server, client, or the transparent. Then we are defining the VTP domain by typing VTP domain and the VTP domain name, because all the switches should have the same domain name to share the VTP advertisements. Then we can also define a VTP password which should match on the switch to share the VTP advertisements again. And to verify the VTP configuration, we are using the show VTP status command, and we can check the VTP version, configuration revision number, and number of existing VLAN, maximum VLAN supported locally, VTP operating mode, domain name, pre-running mode, and something like that.